good day. I am Midshipman Third Class Bautista Kendrick or from MT2 Bravo Company of MOL Magsaysay Maritime Academy. And today we will discuss the spherical trigonometry by using the Napier's rule. So first, let's tackle what is a spherical triangle. So spherical triangle is basically it is a type of triangle that is enclosed by arcs of three great circles. As we can see here, so this is the great circle A, B, and C. So therefore, this is our spherical triangle, the highlighted one, formed by three great circle arcs. That was like a nucleus or a sharingan something. And now let's go with the formula to be used when solving a Napier's rule. So to continue, this is the following formulas that we will use in solving spherical trigonometry using the Napier's rule. So we have two methods and many formulas. The sine cosine opposite rule and the sine tangent adjacent rule. So we don't have to memorize this formula, but we just need to understand its derivation and understand the formula itself. We don't need to memorize it. So first, let me explain the sine cosine opposite rule. So the sine opposite cosine opposite rule, it is the sine of any middle part that is equal to the product of the cosines of its opposite parts. So therefore, sine is equals to cosine of the opposites. For example, sine C bar, cosine of the opposite. Its opposite is sine B and A. So now let's proceed to the sine tangent adjacent rule. So it is the sine of any middle part equal to the product of the tangents of the adjacent part. So therefore, sine is equals to tangent of the adjacents. So for example, the given is tangent C bar, and therefore the adjacent to it, adjacent to the tangent C bar is tangent A bar. We will use the tangent A bar, the angle A bar. The adjacent to it is tangent side B and the C bar. So, and this is the Napier's circle where angle C is equals to 90 degrees. And this triangle, it is called a right spherical triangle. And in Napier's circle, A bar is equals to 90 degrees minus the angle A, and B is 90 degrees as well minus the angle B as well as to C bar. So always remember that if we are using solving for right spherical triangle, we will use Napier's rule. But if we will solve for oblique spherical triangle, we will use law of sines, law of cosines for sides, and law of cosines for angles. And it shows a different formula and different to the Napier's rule, but later I will show it. So now we will proceed to the solving of the four problems. So in this first given problem, a spherical triangle ABC has an angle of C is equals to 90 degrees, and the sides of A is equals to 50 degrees and C is equals to 80 degrees. So first we will illustrate the problem. So since the angle C is 90 degrees, therefore we will use a right spherical triangle. And the most applicable to this right spherical triangle is we will use the Napier's rule. So first, let's draw the Napier's circle and input the given. So since the angle C is a right triangle, right spherical triangle, angle A and side C and B will be a complement to the angle C. So as we can see in the Napier's circle, the most applicable is the sine co-op rule. So we will illustrate first the Napier's circle, then input the values in order for us to determine what formula is most applicable. So in here we will use the sine co-op rule. Sine C complement is equals to cosine B times D. So since C is equals to 90 degrees, we will deduct the value of the cosine complement C. Then we will substitute the values. Then we will derive the formula using cross multiplication in order for us to find the given, the required. Then we substitute the value. We conclude to the cosine B is equals to sine 10 degrees over cosine 50 degrees. So the answer will be 0.27. So in the given problem, it is required to find the degrees. So we will use the arc cosine, the inverse method, because if we will convert it to degrees, we will always use the inverse method. So therefore, the side B is equals to 74.33 degrees.
So in this given problem, we will illustrate first the problem and input the values. So angle B and A is equal, so therefore it will become both 80 degrees and 80 degrees. And the side A and B is also equal, therefore they will become both 89 degrees. So as we can see in the illustration, uh, we will dissect the illustration, the triangle, spherical triangle, in order for us to have a right spherical triangle. So this is dissected. It means that this side will become C over 2 and C over 2. Then we will illustrate the right spherical triangle, and therefore we will just dissect it, and we will have height and same values. Then we will draw the neighbor circle in order for us to determine what formula is the most applicable. So we will input the values using the clockwise direction. So just input it. Then so we will focus on the three significant elements, and here our middle part is 89 degrees, and we have the adjacent C over 2 and the 80 degrees complement, and then we will solve. So we will use the sine tangent adjacent rule. So it will become sine 80 degrees complement is equals to tan 89 degrees complement and tan C over 2. So since we will always divide minus subtract it to 90 degrees, so it will become 90 degrees minus 80 and tangent 90 minus 89 degrees. So we will transpose the tangent C over 2 because it is the required to find. So tangent C over 2 is equals to sine 10 degrees, the the value, the answer that we have come up, and the tangent 1 degrees based on the subtraction that we have conducted. And the answer will be 9.948, and we will use always the inverse method in order to convert it to 2 degrees. So therefore C over 2 is equals to 84.26 degrees. But the value that we need to find is the side C. So therefore we will multiply it to 2 because we dissected it, the spherical triangle. So just multiply it to 2, and we will come up to the answer of side C is equals to 168 degrees, 168.52 degrees. That's all. So in the third problem, we are given a side A is equals to 80 degrees and 115 degrees to side C, and angle A is equals to 72 degrees. So in this problem, as we can see, it is a oblique spherical triangle. Therefore, we will use the sine law, and the formula for the sine law is sine side A over angle A, and so on. So we have a triangle, and this is the side C. Just illustrate the problem as the given, and then so we will just derive the formula after the most applicable formula is the sine law. So we will just derive it, and always derive it by cross multiplication, finding the sine angle C. So we have come up to the formula that sine angle C is equals to sine side C times sine angle A over sine side A. So we will just substitute after we have concluded to the formula, and once we find the answer, we will use the inverse method because we will find to the degrees, and we will use the inverse method because there is no angle given, so therefore we will use the inverse method. So in here we have come up to the 61.07, the value of the angle C, but it is not yet the final answer. So we are not done yet. We will verify it using the formula of sine 180 degrees minus C is equals to sine C. So just input it on your calculator, and as we can see here, there 1. So it come up with 1. So we will we will subtract our 180 minus 61.07. Because the larger one is the angle C, so therefore we will use the 118.93 degrees, basically because the side C is 115 degrees. It is the longest side. So basically the angle C is the bigger one, must be the bigger one. So therefore, we will use the 118.93 degrees based on the analysis in the given figure. So it is an advantage if we will illustrate the the problem first before solving it and calculating it. So in this given problem, we're given an area of the spherical triangle of 327.25 square kilometer. So what is the radius of the sphere if its spherical axis is 30 degrees? So the spherical axis is basically angle A plus angle B plus angle C minus 180 degrees. So it is the excess of the unspherical triangle. So when we are finding an area, A is equals to pi r squared times spherical excess over 180 degrees. So in here we will derive the formula in order for us to find the radius. So it will become 180 degrees times area over pi times excess, and then it is equals to radius. So it will, since it has a squared, we will use the, what do you call this, the square root. So we will square it to and substitute the values. So therefore we will substitute. So r is equals to the square root of 180 degrees times 327.25 square kilometers over pi times 30 degrees. So we just input this to our calculator, and the answer will be, the radius will be 25 kilometers. That will be all to the spherical trigonometry.